Hi, my name is Sleman Saliba. I'm the Global Product Manager for Energy Management and Optimization at ABB Energy Industries. Today, we will talk about connected energy solutions, how to increase energy efficiency and make your sustainability goals with sector coupling and hybrid power plants. But let's look at our energy system first. In the past, we had a few well-controlled generation units. They were producing exactly the amount of energy and power that was needed by households and industrial sites. This has changed, and this change is disruptive. More and more smaller and smaller decentralized generation units, mainly volatile and from renewable generations, are coming into the energy system. And what we are seeing now is a bidirectional energy and information flow. And this adds complexity to our energy system. The focus now is how can I control and optimize the energy system efficiently and profitably. And that's not the end. What we are seeing is that more and more smaller and smaller generation units will be added to the energy system, and they will interact with flexible and controllable loads and storages. And these systems will interact with each other locally, regionally, and globally. And this is a really complex task to manage such a system. But why? Why is that happening? Wasn't it good enough in the past? No, it was not. We, as society, we have goals and ambitions. And one of the goals is to keep global warming below 1.5 degrees. And in order to have a glimpse of chance to keep this limit, as agreed in the Paris Agreement 2016 by almost all countries, um, countries have issued targets on when they become carbon neutral. So, for example, here the European Union has pledged to be carbon neutral by 2050. The UK said they will achieve net zero in 2050, and Germany says to achieve that by 2045. But again, why are these targets affecting the energy system much? And here I have a graphics that's Germany, but I guess many other countries look quite similar. The way we are producing our energy in the past and today is the single biggest contributor to greenhouse gas emissions in Germany. And that's why such a focus is put on reducing greenhouse gas emissions from the energy sector. However, these are all macroeconomic targets. And there is another side to the coin, and that's a microeconomic level. More and more industrial businesses have their own self-imposed sustainability goals. This, for example, is a survey that was made before Russia actually attacked Ukraine, and already then 79% of the interviewed companies said that they are investing and planning to take energy efficiency measurements. 90% will increase their spending over the next 5 years, and even more than the half of those companies plan to achieve net zero in the same period. And this is an impact, from a macroeconomic as well as from a grassroots microeconomic level. And for that, in order to make that happen, you need connected energy solutions. For example, energy management and optimization. So typically energy management and optimization solutions, they consist of monitoring and reporting part, making it visible what is going on your site, on your plant, identify areas of improvement, making it easy to report according to legal requirements. But then, in order to really make an impact on energy efficiency and efficient production, you need to go the next step to control and optimize. So to close the loop from the planning system to the assets, to the controllable loads and the generation units in the field. And with predictive optimization and real-time optimization, you actually plan ahead and send the set points to the field. And then the third part, with advanced process control, you can actually look into the process and to make the process itself more efficient. And you can do that on the one hand, on the left-hand side for decentralized generation units, we call virtual power plants, or at an industrial site to reduce carbon footprint and improve production processes. And you can not only look at energy, where is my energy coming from, where is it consumed, at what time. No, you can actually combine that with different energy types and energy sources. And that's what we commonly call sector coupling. So combine electricity with steam for steam and power optimization, electricity and thermal, for example, for district heating optimization, or for reduction of waste heat, or electricity with hydrogen. Hydrogen itself, to produce it with an electrolyzer, for example, or with a steam methane reformer, that's a very complex process, especially if you have different sources where your energy comes from, and a downstream process that demands hydrogen at different times for different levels. And balancing that out in a cost-efficient way and in a way to reduce wear on your electrolyzers, that's not a simple task. You need energy management and optimization for that. And then, of course, we talk about carbon capture solutions and so on. But that's what we mean with sector coupling. And if an industrial site has different energy sources and combine them and couple them and manage and optimize them together, that's what we call a hybrid power plant. Here you can see a couple of examples. So for example, when we look at electrical side on itself, for example, for virtual power plants or renewable power generation, then it's about where does my energy come from? How is it consumed? When can I buy it at the best price? And can I identify my biggest consumers? And then you can combine that, for example, with thermal for the exploitation of waste heat or for optimizing district heating plants and networks with combined heat and power plants, for example. Hydrogen, we quickly touched base on that. It's to enable a circular process. So where is my energy come from which source? You can have different sources. How is the hydrogen produced and how is it utilized afterwards? And that's quite complex if you look at that. And then the steam, especially for process steam in industrial sites, that's also quite a complex optimization problem to keep the steam network in balance, and coupling that with the energy side as well. How can I use my energy that produces the steam for the process plus the electricity for either the industrial side or feeding it back to the grid? That's even more complex. And putting that together, combining that and optimizing it together, you can leverage quite a substantial amount of savings for your industrial site. But let's look at a couple of examples where connected energy solutions have been deployed for the benefit of the company and society. So Kligas Flak is a very prominent example. There are 4 wind parks in the North Sea, Baltic 1 and 2 belonging to Germany, Kriegers Flak A and B to Denmark, and the energy management and optimization system used here was used to do real-time optimization and predictive optimization in order to monitor the power flows between the 2 countries and to optimally distribute the generated energy to the 2 countries based on grid lines, based on demand, based on energy prices. And in this way, we can improve the harvested wind energy from an unbalanced and unoptimized system. And that's more than 1 gigawatt. So that's really substantial. So from the point of it's critical to actually be able to monitor the power flows, as well as there is an impact if you do it in a proper way. Another really nice example is from Zentralschweizerische Kraftwerke in Switzerland. That's a virtual power plant. So combining decentralized power generation units together and manage them together. So the first step was to actually put proper automation in place so that the trading department always knows the flexibility in the field, and on the other hand, to optimally stand for 3 different ancillary service markets, the calls and the set points in an optimal way to the decentralized generation units. And that was really a nice project and a big task, because 3 different ancillary service markets with different time frames sending their demands, their calls to CKW, and then one after the other need to be distributed and sent to the field units. And on the right-hand side, our first installation on hydrogen, that's for EDF Hynamics in Auxerre. And here we prove that with an energy management and optimization system, you can actually balance out or orchestrate a highly complex integrated energy management system for the hydrogen production. So in real time, you optimize the electrolyzers, so it's green hydrogen, and with the predictive optimization, you actually look, where does my energy come from? At what cost is it produced? What's the downstream process? Where will it be used? And how can I use the hydrogen storage in the best way? And all that taking electricity prices, asset availability, and ramp rates, and all the side effects and side constraints that you have. So we have seen some outstanding examples for connected energy solutions that really help to improve energy efficiency and meet sustainability goals. So we can together make a difference. And I truly believe that the integration of renewable power generation and sustainable industrial productions are essential to protect our world for future generations. If you or your company want to make a difference with energy management and optimization, then contact me or anyone at ABB. And with this good news, I say goodbye and thank you for today.